Welcome to the first ever Sustainable Spark Tank. Today, we've got 4 brilliant young entrepreneurs here to present some game-changing solutions that show we can create prosperity while we're saving the planet. I want to start by introducing our investor judges who are here today to help us. We've got James Rich with CurvePoint Capital, which is a climate-focused growth stage investor. And we've got Logan Grizzell of Muus Capital Partners. They're an early stage climate investor. Some quick ground rules for today. Our young entrepreneurs will come up and present for 2 minutes, doing a quick introduction on their company. And there'll then be a brief time for some Q&A and some feedback from our investor judges who can then help critique their presentation as they continue their growth strategies. There is no expectation of any offers being made here today, just to be clear. That said, let's get started. Let's begin with Silvia and sustainable chemicals.
Hi, hello everyone. My name is Silvia Luebben and I'm the CEO and founder of Sustainable Chemical. At Sustainable Chemical, our focus is to develop the next generation bioplastic to replace single-use plastic. You may have heard that each of us eat about 1 credit card worth of microplastic per week, and that is going to grow to about 5 credit cards per week by 2050. That's a lot of microplastic to eat. There is a significant increased demand for sustainable products that is driven both by consumer, brands, as well as legislation. Unfortunately, existing bioplastics have been around for 3 decades and managed to gain only 0.5% of the global plastic market. This is because they're just too expensive. This is why we create Replose. It's the next generation bioplastic. It's 100% plant-based, so has a low carbon footprint. It's 100% biodegradable, means no microplastic at the end of life. And we specifically engineered the plastic chemistry so it could be cost competitive with petrochemical ethylene. This is the cheapest plastic on the market that is used to make meal jack, plastic bags, films, and many other items. Our first market is industrial plastic wrap. It's a $4 billion market. And ultimately, our aim is to replace polyethylene, which is a $100 billion market. We have received significant traction, including 5 patents, several grants, and have established a collaboration on the ecosystem, and we just received the Colorado Clean Tech Award. Our team includes myself. I have a PhD in polymer chemistry. I have an awesome co-founder with excellent business experience. He's a serial entrepreneur, and we have 2 excellent chemical and a fractional CFO. Our ask is for $1.2 million pre-seed. Thank you, and I'll be happy to answer any question.
Excellent. Good presentation. Great job, Silvia. All right, judges, do you have any questions?
You want to start, since you're the early stage guy?
Or any feedback?
Indeed. So what are you going to use your $1.2 million for?
We are going to, so partially about 550,000 is for complete the R&D development, a process optimization. We would like to hire 2 engineers. Right now we're heavy on chemists. We design the molecules, but we need engineers to take that design into a reactor that can steer viscous system and so forth, and sort of focus more on the application stream. And transfer to a larger facility. Right now we have a 750 square foot facility. We want about 2,000, 3,000. We also want to wrap up our IP. We have several pending applications that we need to enter national stage. International filing, it's expensive and cannot be charged on grant. And finally, we want to establish a little bit more of a marketing business development department.
I guess my question is, what is special about you as the founder and CEO and your team? There have been a lot of people that have tackled this kind of single-use plastic problem by coming up with biodegradable plastics. So why are you any better than they are?
Well, so my experience is I work in R&D for 17 years for a government contract company, and this technology was invented then. I then kind of tired to do the contract, changing topics, and decided to go in chemical manufacture. I want to learn how chemicals are made and manufactured, and then went to corporate. I want to learn how the corporate structure work. And about a few years later, from when I originally patented this chemistry, the manufacture of the raw material changed completely. So someone else in the ecosystem developed a scalable process to make the raw material used for making our chemistry a scale. They are building for commercial scale for the production, and the cost suddenly became lower than ethylene, which is the starting material for making polyethylene, by 20%. That gave us the economic viability that no other plastic has.
Right.
So we own the chemistry of the plastic.
Right. But I've also heard that story a million times from other sort of bioplastics companies that have said like, oh, this is 20% lower than polyethylene. And then as you pointed out, less than 1% of the market is actually bioplastics. So how do you sort of assure your investors today that like you're actually 20% lower?
Because most of our competitors have to use a fermentation process, and we don't. So we don't use fermentation neither for making the raw material nor for making the polymer. That allows the process and the commercialization to be scalable just like a regular chemical from petrochemical.
And sorry, just for my purposes, what does fermentation mean?
Fermentation means you're putting biomass, sugar, corn in a broth, and you're adding enzyme or bacterial, and they are converting to your chemical. At the end, first you have a dilute water reaction. Mm-hmm. You need to put all the bugs in a blender and do complex separation to get your chemical out.
Got it. So because you don't have to do that, it's easier to get to your sort of production?
Yes.
Okay. And what's the path from here to getting to be production scale, sort of commercial scale, producing 20% lower cost than polyethylene?
So our sort of go-to-market strategies, we need about 1.5 years worth of sort of R&D beginning pilots. That's what this funding is for. Once we stabilize and optimize the process, we want to transfer manufacturing to a contract manufacturer. We believe that our process can be fully integrated with existing polymerization plant. And so we just need to find the right spare capacity. That would allow us to enter the market, begin sales, without the capex of building our own plant. At that point, there is an opportunity for an early exit, which we're counting on. But if the early exit doesn't work, then the alternative path is at that point, once we already validated the product in the market using contract manufacture, we will build our own plants.
Silvia, thank you for a great presentation. Close with this. If people want to connect with you, how can the general public find you?
I can find our website at www.sustchem.com, and my email is on there.
Fantastic. Thank you so much, Silvia. Next up will be Ryan with CH4 Microbial.